Hello, in this video we're going to learn a very important topic of integration by parts. And this is the given formula: integral u dv is equal to uv minus integral v du. Now this may sound a bit difficult, but it's not that difficult. So let's see an example. I give you integral x times e to the x dx. So this is like the product rule for integration. If two functions are multiplied, you have to do integration by parts. And you can do this in, again, 2 steps. Your job is to find u and dv from the problem. So compare the given problem to the formula on the left hand side. U is the first thing, x, and the remaining is the dv, entire thing. So you have to write e to the x dx. Now for the u equals x, we differentiate this part and we integrate this part. That's the step. So you do du over dx. What is the differentiation of x? 1. Cross multiply, just like u substitution, you get du equals dx. Count this as one of your results. Now what is the integral of dx alone? It is x, because there's a 1 here. So integral of dv will be v. And the integral of e to the x, you can use the list of formulas, it's e to the x. Count this as your second result. This is the end of step 1. And in step 2, take these two things and plug them on the right hand side. So in place of u, you write x. In place of v, you write e to the x. In place of v, you write e to the x. And in place of du, you write dx. And once again, simplify this. The first remains as it is. Now again, what is the integral of e to the x dx? It remains the same using the formulas. And at this point, you put a plus c. And this bit here is your final answer. You say y equals x e to the x minus e to the x plus c. So the integral of x e to the x is x e to the x minus e to the x plus c. And we did this using integration by parts. Okay, let's do one more. Okay, another important function to integrate using integration by parts is ln x. Now just make a note, if you're doing integration by parts and if the problem has ln x in it, the u has to be ln x, no matter where it's placed. And the dv has to be the remaining, which is dx, right? The first is u, the second is dv. So now differentiate this, these are the steps. Just keep following the same steps, 1 over x. And solve for du here. So du, move this up here, do not move this up there, it becomes dx over x. Because we will need du on the right hand side, that's why we solve for du. And integrate this one. So v becomes x. Using the list of formulas. Now take these results and put them on the right hand side. In place of u, you write ln x. In place of v, you write x because v is x. In place of v, you write x. And in place of du, you write dx over. And then you simplify, the x and x cancels. So you're left with ln x times x minus integral dx. So that becomes ln x times x minus x plus c. And that's your answer. So remember, integration of ln x is done using integration by parts, which is this bit. Now, for example, if there was definite integral here, for example, from say 1 to 2, then you would have to do one more step in which you make two brackets, just like before, get rid of the c. In place of x, plug in 2 into the first one. You get ln 2 times 2 minus 2. And in the second one, plug in 1. And then calculate this. I'll quickly do this. And if you do this, you get 0.3862. And that's your answer. Now, once again, you have to understand, what does that mean? If you graph ln of x, which looks like this, and from 1 to 2, the area is the answer that you got here. You can check the answer, but this is the area that the value you're getting. Very important to understand. Let's try and do one more. Okay, let's try and do one more. Say I give you something like this. X times square root of 2x plus 3. A bit difficult. Okay, once again, the steps remain the same. Find the u, find the dv. So u is x, and dv is square root of 2x plus 3 dx. Do du over dx here. It's 1, so du is dx. This is simple. This is one of your results. Now on this side we have to integrate. Now in order to integrate this, you will have to do u substitution. So this is very important. Inside integration of parts, you have to do u substitution. So you say let u be 2x plus 3. Du over dx is 2. So dx is du over 2. This is from u substitution. If you haven't seen that video, you should go back and see that first and try and do this. So the problem becomes v equals integral u to the half du over 2. Right, in place of 2x plus 3, you put u, square root means half, and in place of dx, you put du over 2. So if you use the power rule here, the answer becomes u to the 3 over 2 over 3 over 2. 2 and 2 cancels. So you get 1 over 3. And you replace the u again, 2x plus 3 to the power of 3 over 2. This is your v. So a little bit difficult, but you have to understand integration using u substitution in order to do this. And now take these guys and put them on the right hand side. So u is x, v is 1 over 3, 2x plus 3 to the power 3 over 2. Right, minus v, which is 2x plus 3 to the power of 3 over 2. And the 1 over 3 can come outside. And in place of du, you put dx. So simplify, you get x over 3, 2x plus 3 to the power of 3 over 2, minus 1 over 3. Now, in order to integrate this, you have to once again do the u substitution. And 2x plus 3 should again be your u. So do u substitution again here with u equals 2x plus 3. If you do that, what do you get? Let's see. So I'm going to do it directly. You get 1 over 2 times 2x plus 3 to the power of 5 over 2 now, because you're adding 1 to the power here. 5 over 2. 2 and 2 cancels. And then you try and simplify. You get x over 3. 2x plus 3 to the power of 3 over 2. Minus, you multiply the 3 and the 5, gets 1 over 15. 2x plus 3 to the power of 5 over 2 plus c. And this bit here is your answer. Now you will only be able to do this properly with practice. You will have to practice quite a bit to do integration by parts. Integration in general is not that simple, so you will have to practice. Okay, any questions, type in below and I can try and help.